Hi, everyone. I want to thank you for coming to my talk titled, Let the Bugs Come to Me, How to Build Cloud-Based Recon Automation at Scale. For the first half of this talk, we're going to go through an overview of how you can build your own cloud-based automation ecosystem. So we'll go through kind of the framework, the methodology, lessons learned, and provide an overview of a lot of the cloud services that you can utilize, and then just talk about methodologies that we can apply so that way all of the challenges and mistakes and the lessons learned that I've had over the past year and a half, you can avoid that as you build this out. And then for the second half of this presentation and talk, we're going to do some live walkthroughs of the actual environment, show how it works, how it runs. And at the conclusion of this, I'll make sure to release the majority of the code that you'll see today, so that way you can reference it and hopefully you can take it and build out your own environment and drive that success for Recon. Additionally, I posted earlier this week a supplementary article that I'll reference on the slide here, and feel free to pull up the link and kind of follow along as we go. The talk doesn't go line by line with it, but I think if you want to delve in and try to gain more information throughout, feel free to jump in there and leverage those resources. There's a lot of live code snippets and pieces that may add some background context. So I wanted to share a little bit about myself. My name is Ryan Elkins. I'm a husband, I'm a father, I have 2 kids, and by day I'm an information security architect. I spend the majority of my time learning about cloud solutions, how to secure cloud, and my primary focus is cloud. And eventually, once the kids are in bed, 10 o'clock rolls around, I like to try to be a security researcher and hack things when I can, when I have the energy. And so that's really what led me into this talk, is that limited time factor, where a lot of times the free time that I do have starts at 10 p.m. at night. However, at the same time, I still want to be able to participate in learning and bug bounties and in doing a lot of the hobby security work that I really love. And not to mention that it helps me out in my day-to-day career as well. And we'll share some different lessons learned. But leading into that, I guess it reminds me of a story, and I'll call this the Blockbuster Dilemma. And I'll ask the audience here, does anybody remember going to rent movies and actually walking into a store or into a Blockbuster and you actually go and pick it out? Well, if not, I'll walk through the process. And I think there's a lot of carryover traits to at least my experience with bug bounties. And so you're sitting here on a Friday night, you just finished eating your pizza that you just had a carry-out dinner of pizza, and you realize, hey, we have 4 hours to do something. Let's watch a movie tonight. So you get the family in the car, you drive to the nearest Blockbuster or grocery store, wherever they have movies that you can rent, and you go in, you spend about 45 minutes trying to get a movie that everybody agrees on. You eventually compromise, you pick the selection, you drive home, and then you make some popcorn, you go upstairs, you drag down all the pillows and blankets, you get everything in front of the TV. You eventually start the movie about 2.5 hours later. Say you're down to maybe an hour and a half. You get the movie started and you fall asleep. You wake up the next morning and you realize, hey, I missed the whole movie. I'm going to try to cram in the movie before I have to return the movie that day, or you get fined. And you eventually end up missing the day by like 10 minutes and you pay for an extra day. That is exactly the challenge with bug bounties. And I feel like we are reliving the times of the VHS rentals and the DVD rentals. Picture a bug bounty. This was me before creating, and what drove me to build this ecosystem that I'm sharing with you today is you get the kids to bed. It's 10 p.m. I decide I want to hack tonight. I'm going to work on a program, try to learn, figure things out. So I go in, open up the computer, I log into every single platform, see what's available. I review all the programs. I look at my private invites. I look at the public programs. I dig deep trying to see maybe there's a public program somebody missed. You do that every time, even though you don't always find something. And then you also look at what programs have incentives. And eventually you get to the point where you select a program. So you have your program. Now you need to find all those SSH keys that you forget where you store them on your computer, or what password did I use to log in. So you get all of that together. Then you realize, hey, I haven't even started my VPS server. And so you start at the VPS server, and then it starts up. You fire up Burp Suite or whatever proxy you use. You start manually converting these scopes over into your Burp Suite console. You get everything ready, then realize, well, I don't want to just go for that root seed domain. We should do some recon. So then you figure out, you update a mass, and you go out and you look up the syntax. You get the syntax, you load it up, run it, you kick it off, you wait about 10 minutes, you get tired and you fall asleep. You wake up the next morning and you just realize that you just slept all night while a mass is running. You have this big arsenal of subdomains, but you're going to have to wait another few days to be able to tap into this. So your whole night was basically gone because you only have a few hours. Your time is so important. And for me, I was living that over and over again, where I would do this, I would have this recon, and then the next week I would just decide I'm going to go for a different program to do. And it's really a systemic issue that probably a lot of us face. And I hope some of this resonates with you and some of the challenges. So I needed to figure out a different strategy, a better strategy. How do I solve this? And I loved it. And I thought, a couple of weeks ago, I know Codingo, Michael Skelton, and Heath Adams, the cyber mentor, were talking on Twitter about comparing poker to bug bounty. And that really resonated with me because it fit the exact objective of what I've been trying to accomplish with this automation. Is I wanted to build this scalable, cost-effective, cloud-based platform that can do full recon automation end-to-end. So that way it takes all this raw data and transforms it into actionable intelligence. And for me, the poker comparison is that the best poker players, they don't play every hand. The hands that they play, they want to make sure they have the best statistics and the best chances at winning that hand, and they play it. In the same way, the time that I manually spend on a program or doing analysis, I want the highest likelihood of signal versus the noise that I'm going to find a vulnerability, whether it be a duplicate or not. I don't care at that point. I'm just happy to have proper raw or actionable intelligence from the raw data that I can act on. So that's the ultimate goal. And I feel like this program that I'm going to show and walk through, we come pretty close to that. And we'll talk through that as well. So as I developed it, I thought about it, and I thought there's actually, I categorized into 9 tenets that I felt important to make sure that I'm always guiding towards. And I definitely didn't hit every one of those, and there's still iterations and MVP and post-MVP processes, but eventually I want to stick as closely as I can to these 9 tenets. And I think it's important as you think about this as well, that they all resonate and make sense. So the scales horizontally part, this solution had to cover every bug bounty program in existence. I'm not smart enough technically to be able to be writing my own exploits in 0 days, but I am smart enough to apply the OWASP top 10 and search for those and some of the common themes that we see and we read about and we learn about. The problem is I can't just hone in on 5 things and ever find it. So I need to be able to scale that breadth of knowledge across every single program at once. The other part was scaling vertically. So I want something that now once I have the data, the intelligence information, the fingerprinting, the server information about every single program, I can continue to add new checks things. So the scales vertically are kind of your bug classes that you're checking for across the entire ecosystem environment of bug programs. The other piece is I want it to be cloud-based. I don't want to have to stand up my own server racks and run capital investments of hardware and things in my home office. I mean, that had no appeal to me. I want to be able to have on-demand scalability. The same reason that businesses are driving towards cloud are the same things that I wanted to do. I need that compute power when I need it, and I want to make sure that I have it at my fingertips. So cloud-based is extremely important with no on-premise dependencies. The other piece is infrastructure as code. So being able to deploy your infrastructure repeatably and source control and version control and all of that is really important. I've failed quite a bit in this area because a lot of times I'm just working on something and I want to make it work and I can go in the GUI and click. So that's probably the area that I have the most technical debt that I need to revisit, but certainly something that I'm working towards. Robust documentation. For me, I could write a line of code and I could forget what it does the next day. So being able to kind of understand why I did something a certain way, have articles about it, explaining it, that way I can revisit this and not have to continue to relearn that. And then it also helps with sharing to the world and to the industry and making us all better for the same things by having some statements and documentation around it. Low cost is another piece. It can get really expensive as you start standing up multiple VPS servers and running containers and cloud services. So my goal is to keep it within the price of finding one low vulnerability per month. I'm scaling right on the edge between like a low, medium, but my goal is to optimize this as much as possible so that way I can basically one low vulnerability per month will pay my cloud bills. Now, hopefully once we scale vertically, it's going to gain more expenses, but that hopefully means there's more success being driven and it's not as big an impact financially because it's generating a profit at that point. The other piece is aggregating the data analysis and anomaly discovery. So I want this raw data and I want it to be aggregated across different tools and pulling everything together so I don't have to individually go and look at one tool's output and then the next one, but bringing it all together to make the most relevant intelligence possible. Being a security practitioner myself, security best practices are also important. And I think that our program owners care about that as well. I mean, they're giving us the opportunity to go do recon, find potentially damaging multi-million-dollar impacts to these companies based on some of these Sev 1s and criticals. It's important that we take our own due diligence seriously around the data that we're collecting and harvesting from these programs. So that maybe performing least privilege, changing passwords regularly, doing encryption in transit and at rest, and just general good security hygiene. Then the last thing is version control. The last thing I want to do is spend a year on this and make a mistake and have no idea what I broke or lose the code or delete something. So keeping this in GitHub under version control is extremely important and super valuable. So I want to jump into this architecture. What am I actually talking about? Why are you spending your time today to learn? And I think one of the things that I'll ask of you as you listen to this is looking at this. This is the actual diagram of the architecture that's built out in the cloud, and I'll share the code and you'll see it all working in different things through follow-up articles and code that I'll release, and we'll walk through a few examples within here. It's a fairly large ecosystem thus far, so we won't touch on everything in detail today, but as you think about this, even though this talk is more focused around bug bounty and recon, this applies so effectively to pretty much any area of information security. And I would even extend that to any area of IT or technology. I mean, if you work in incident response or doing any types of forensic analysis or vulnerability management, or even if you're a risk analyst or someone that's maybe not developing code or in quite as technical of a role, this is basically just taking data, turning it into intelligent decisions, and using orchestrated workflows. And that's basically the extent of this, but doing it properly can make you extremely successful. And leading into this, I feel like just in general across the industry, if you're looking for a niche to really fill, it's leveraging cloud to further mature your company's security program. And I think if you go out and search for articles, you're going to see a lot of information and data about how do you secure the cloud? How do you secure cloud services? You're going to see a few things about how do you hack the cloud? How do you do that? What you're going to find very limited is how can you leverage the cloud to actually transform and mature your own security program, your own security processes. So this is just taking one niche area of bug bounty and recon, automating that with cloud services, but this could absolutely apply to all areas. And I would challenge you to start to use this within your own job roles as well. So what happens in this ecosystem is I'm actually tying into all the major bug bounty platforms, and I'm using it's an existing GitHub repo by Arkady Tetelman, and he's actually going through and making a lot of the API calls and scraping the programs and sites. So eventually I'd like to get directly integrated into every single platform itself and not have that as a dependency, but I'm using the raw JSON output that he's developed and published out to the community, and I'll reference it here for you. And so I thank him for the awesome project he has out there and available to everyone. And I've been able to leverage that. And through that, I can bulk load every single project out there that's at least in the major platforms. And then there's always the situations where you need to load maybe an external one that I want to do ad hoc or something. I also have the ability to make an API post request that will load that program. So once you have all the programs loaded, it's then literally just a GET request with the program name that I want to initiate this recon cycle on. It steps through every single thing you see on this reference architecture, does all automation. It kicks off HTTPX scans. It does domain enumeration through Project Sonar. It has a mass module that I'm not going to talk through in detail today. I'm not using it as extensively right now. I'm more interested in hitting some of the data sources directly with their APIs. But then once it gathers all of that data from the initial scope, it will then kick off a HTTPX scan that gets kind of your URLs and gets some of the base ports and the fingerprint details and the response codes and everything. And after it has that, it will circle back and it will do a web crawl of all those seeded base URLs. And then the nice thing is iteratively, whatever URLs it finds, it does the JSON, the JS link finder. It looks for everything, API endpoints, analyzes all that, pulls it back, gathers a list of every URL found in there, whether it's in scope or out of scope, does a double check to make sure that everything is back into scope, creates that list, feeds it back into the recon process, does the recursive recon, and then goes back through, and it will keep cycling through until it gets tons of information, all the raw output. Then as it's done and completed, it will do commands that aggregates the raw output all together, and you basically get into structured formats that you can query, you can search, you can sync it to persistent systems and run tools like a semgrep or a sift or a regular expression, whatever you want to. You could even do, I'm using nuclei templates locally against the file, all the responses that are stored across millions and millions of web pages. So there's unlimited amount of depth that you can do once you have data basically curated in a usable format. The overall infrastructure is broken into really three main components. There's program generation, program operations, and program analytics. And that's kind of how I bucketed everything that goes on. So this is an example of what you would start with. So if you want to do recon on, in this example, you can see I have Tesla. So I want to say I want to do Tesla. This is initial operation. The nice thing about this too is that if I want to just do like a crawl, I would say operation crawl, and it's going to crawl the existing data I have for it. Or I could say HTTPX, and it'll do an HTTPX scan against the URLs that we have for it. But in this case, this just says do the entire recon. So it's going to kick it off, and at the outcome of, without touching anything else with just this post request, I'm going to have dashboards like you see below where I can have real-time analytics and filtering capability around the URLs, their status codes, their responses. And this isn't going to tell me specifically vulnerabilities at this point, but this gives me a way to filter through and structure this so I can have the most highest likelihood of signal through all of the extensive noise that we've discovered through the recon process. And then I think Graph Database is a really powerful visualization tool to quickly see those anomalies that are sitting. And then you can also see relationships. And this is a Neo4j that's running within, it's the Neo4j cloud service, but it's issued through as a third-party Google Cloud API. So I have that. I'm not using it as extensively because cost-wise, I don't think, honestly, I can afford it to run it across all the programs. It's great for like one or two programs, but once you start hitting those node limits, it just gets too costly to expand that out. So maybe once we start having some return on investment, we'll do more there. But I'm using NetworkX locally with the Python libraries, and you can still generate some raw analytics around some of the individual programs, which is fascinating. So it really starts with the program generation. It's important to have all the programs loaded, ready to go. And that's where I talked about Arkady Tetelman's bug bounty targets GitHub repository. That's just awesome. And you can go through. But I will highlight one of the challenges that I faced early on is with scope. Being so important that we stay within scope. The program owners care about scope for a reason. And a lot of times these companies, they want to be able to have these programs and do this, but they truly are sometimes systems that maybe are legacy, or they know that it's not going to handle the traffic. It might be that they're just not ready to have everything within their ecosystem or environment to be hit by thousands of hackers across the globe. And I think that's fair. And I think at the same time, for us as researchers, it's important to honor that scope and make sure that we stay the best we can within scope. And what I quickly found when you try to automate across everything is that it's difficult because the scope, even if it's in the same exact field, varies significantly. So I've tried to build and iterate over different scope types where you might have a URL with a wildcard at the end of it. You might have a domain with the subdomain wildcard, but does that mean that I can also wildcard other pieces of it? And then there's CIDR ranges and IP addresses, and you'll kind of see the different variations here listed. And one example I learned pretty quickly is making sure that GitHub's not included as the in scope whenever they have a repository there, because I quickly learned that you start crawling GitHub, you get a lot of responses, and it can really take a long time for unnecessary scope. So I made that mistake once and have fixed that pretty quickly. So, but tons of lessons learned like this that I never anticipated when I started on this journey of developing this environment. And then you can see if you want to load a new program, the post request payload is right here, where all you have to do is provide the program, the scope in, the scope out, the platform, and the invite type. So that way I can filter and protect any private repositories or programs without, whenever I'm doing demos and things, I can better hide those. So that's pretty much all it does. And it is all loaded and stored inside an AWS DynamoDB. So it's structurally maintained. And then I have a timestamp field where I can then trigger and say, once I have this and I run Recon, I set the timestamp so I know when the last time I ran this again. So if I want to start doing more automation around, if I haven't touched the program in 30 days, let's automatically kick this off. And those are all future enhancements that I could do, but just trying to track the program. So you can see in the screenshot right now, I have 653 programs loaded. I know I have a couple other places to pull programs from, so that's definitely not comprehensive yet, but that's certainly enough to get started with. And then the operations piece is everything is initiated via API. So there's nothing that you have to do outside of an API curl request if you have. So it's you make the curl request to the AWS API service. You can set your own custom CNAME. I have api.brevityinmotion.com. That's kind of where I host my blog and other things, and I've leveraged that. So I make the request there. What it does is it feeds in, and you can proxy that API call to what's called AWS Lambda. And picture the AWS Lambda service as a serverless function that is running, and you think about like Python functions. That's pretty much you want to leverage these as small modular components that do one task, and they do that single task well. And so I proxy that API call, and then the parameters I send in the post or get request to get filtered in as arguments into that function. So it's just a quick way to make a function API based. And that's awesome. I mean, just think about that power alone. Where in your company that you write a Lambda or a Python script or have some type of thing that you want that takes arguments and it maybe runs on the server today. Throw it in there, proxy it through the API gateway, and now you have an API call to some type of data processing that you could kick off. And that's just so powerful in itself to be able to apply to so many areas. And then once those functions run, they output all the data into S3 buckets, which are object-based storage that just scales along with however much room that we need. The other piece is ephemeral workloads. So I'm actually anything that I perform actively against the target. So those are the web crawls and the nuclei scans or anything like that. That is all stood up dynamically on ephemeral droplets within DigitalOcean. So I use DigitalOcean droplets for everything that I do, and it pretty much writes a custom startup script where I start up the droplet automatically via API. It feeds the startup script to it, and the last command that I have in there is shutdown. So the startup script also completes all the work, synchronizes the data, queries AWS S3, pulls all the data in, and then runs its processes. And then the last step is synchronizing the data back to S3 so we don't lose the output. And then it shuts the instance down. And then I have a Lambda that runs every 5 minutes that's always querying my DigitalOcean account. And anytime that there's a droplet that's shut down, it will just terminate it so I don't get charged for longer than the duration. So worst case, I have 5 minutes of extra time runtime from every operation I do, and it just over and over sets up ephemeral for every process. Then it's very modular. So that's how we do it. I'll share all the code. You'll see snippets. You'll have, I think that's already in the supplementary article, so you'll be able to kind of see how I do it. But it's really that just-in-time dynamic approach that I've been leveraging. The last piece is the program analysis. And I know I already mentioned the data is stored in AWS S3 buckets, but I have buckets for raw data. I have data or buckets for refined data. I have buckets for data sets that I pull in from like third-party sources. If you think like the MaxMind APIs for ASN lists or GeoIP and all of that. And then there's a curated/presentation area where you can do the presentation pieces where I might point what you see here is a quick site dashboard, and I'll point to that data and it correlates, aggregates it all, scans it through, and presents it back to me in where I can have the visualizations and the summarized output of it, so I can make better use of my time and not dig through thousands of individual text files, which I know a lot of us face and struggle with today. All right, well, with the time left, I think we should try a live demo. Let's try to walk through the Recon engine end to end in the workflow. And as we go through it, I'll explain what each step's doing and try to fill in all those pieces. And I think that will probably wrap up the rest of this talk, but there's going to be tons of follow-up information. I advise that you follow me on Twitter, check out the blog, and I'll continue just to post more and more information so you can replicate big chunks, or if not all of this, yourself personally. So let's go ahead and jump into the AWS console here. So I know earlier I mentioned you can kick things off with a curl request and do all of that. You can actually test directly within the ecosystem as well. So I'm going to just jump straight into the API gateway. This is the API structure that I currently have set up within here. Since we're going to test out adding a brand new program to here that doesn't exist anywhere else so far, we're going to go ahead and check out our post request, and we can kind of see the structure of how this is set up, where it's going to go through the API, it's going to get proxied straight through and hit this backend Lambda for a post request. And one thing I don't think I mentioned yet is that I do all of the development within Cloud9, which is another AWS service, which also makes it so I don't need any crazy powerful laptop. All I need is something where I can get to the browser and do that development. So I'll show you. We'll hop into the Cloud9 development environment here. So this is what the IDE looks like. It looks very similar to like a Visual Studio Code or something like that. But what we're going to do is I have some test cases written out here for example. So as I'm going through deploying new code or anything, I can go in here and get some quick examples. So we want to do a post request in here. So I know this is an example if I want to test this out. So let's copy this over and let's put this into the API post request gateway. So we want to test out this service. And if it's a GET request, we'd put it in here. You can add some custom headers or anything like that. We're going to go straight to the request body and paste this in. Now, this program already exists. So just for demo purposes, this shows something that's completely brand new. Let's call this Recon. Let's actually call it DEFCON Recon Village. So we'll start. That's going to be our program name we're going to look for. Here's our scope in. So we're going to give it a wildcard to make sure that we can do some additional recon steps, add another site, and let's put an out of scope site as well, and then we'll call it an external platform, and this is all my own. So what we're basically going to do is crawl my blog for sites. So we're going to kick this off here. We're going to say test. We should get a response in a second, which tells us whether it successfully loads or not. Let's hope for success. Program successfully created. So it created the program, and it's most likely entered into our step functions functionality here. So let's go into AWS step functions, and this is our orchestration unit. So we can see it's running right now. So let's click in here and see what it's doing. And I love how you can get kind of a visual status of what all it's going through. So as we go through here, it hits the first choice, and it kicks over to program build based on the operations we send it. So it built the program, loaded into DynamoDB, and then what it does is it checks the build status. If it was successful, it goes in and goes ahead and does a Sonar query against the Rapid7 data set of basically the 4 DNS services. And so it does an AWS S3 bucket query using the Athena service here, and it's in progress. So it's pulling those results back. So if we were going to go into the Athena service here, we can actually go and look at our query history, and we should see the current query it's running against the Rapid7 forward data set. And so here's what it's running exactly. and it just loaded. I guess I clicked it. So we have it here. So this is what it automatically generated. It's pulling the results back. And once it completes, it looks like it completed successfully. It would have stored those results into an S3 bucket. And now it's doing running HTTPX. So since this is an active process against the actual target being my website, it's going to kick off a DigitalOcean droplet to run this command, and it's going to build, install it, everything from scratch. So if we go over here into my DigitalOcean account, you can see that this droplet just finished getting created, the IP information, and I have a naming structure so I know at least which program it results to. So while this is running, it's probably loading up everything. It's going to do all the installs. We'll keep an eye on that, but we'll talk through some other steps as it goes. So let's jump back to the step functions. So far, what is really neat about step functions is you can do something called callbacks. And one of the limitations with the Lambda service is that a Lambda can only run for 15 minutes and you're charged for the duration that it runs. And so when you're doing something like a web crawl or an HTTPX scan, you really don't want your Lambda function waiting the entire time for that to return back. So what we did was we called the Lambda kicked off the program or the operation, built the droplet, and then the Lambda completed. So it closed. So right now we're not getting charged anything within the AWS ecosystem for running. And then this step function state machine is waiting on what's called a callback. So whenever I built the droplet in the startup script, I added a callback task that says, when you get to the end of this, the last thing to do before shutting down is to make an API call to the step function service in AWS and tell it that you've completed your journey, and then success or fail. And when it reads that in, it will determine where to go next in the workflow. So this workflow is essentially in a pause state, just waiting on that callback to happen. So we'll give that some time and see when that happens. What else can we jump into here as we're talking about that? Let's check out some of the actual Lambda function that ran for the program build. I think that's pretty interesting. So let's pull up. These are our Lambda functions here, what they look like. So we're running HTTPX. So let's look at operation HTTPX. And so basically it's listening for event context. Every single Lambda has this same kind of format. So it was sent an event into it, and you can see the events get triggered as it goes down through. So the operation HTTPX, we can click here and we can actually look at the step input and see that this is what was submitted to that Lambda function. So it submitted the program variable and the operation. So when we go back to that Lambda, we will be able to see where we basically we pull in some of the data parameters, and then we check, does program exist and does operation. As long as we have both of those things, we know we're on track, we have the right status. It's going to go ahead and run. So it's creating some initial file names of the domain, storing in S3, and then here's some other commands where it says prepare HTTPX, generate the install script. So let's hop in and check out the install script. I think this is one of the coolest things that it took a while to figure out, of thinking through, how am I going to manage scripts across 600 plus programs? What if I want to make a change to the syntax? Or what if there's a project update where I need to add a different command or something like that when you're reliant? So what this does is it generates these scripts based on the runtime dynamically just in time. So I don't have like a bunch of scripts just sitting ready at program build. This actually gets generated on the fly immediately before the program before the operation's initiated. So I only have one central place within the code that I need to update these scripts, which makes it really easy to make changes and modify and keep things up to date as we go. So what we'll do is we'll jump down into the code that does that. And what it is you can see here, like for generate script HTTPX, what this is doing is this is writing the file using Python code, generating this file here. So this is actually the operation, what I'm using. So you can see the HTTPX command here, passing in my program name parameters. It gives me a program name defined output, so I know which one it comes from in the JSON. And then I'm telling it kind of the syntax of what I want from it, everything. And then store your responses. So I'm storing raw responses locally on that droplet that's running. And then eventually you get to the point where it gets down, it gets everything finished, it processes it. At one point I was actually tarring all the responses up and just storing them, trying to save space and compatibility, but it became easier and more difficult and time consuming to continually untar the files, do that, especially when you're getting into the millions of files individually. So it just does a copy over to S3. This is the sync script that it's just another script that's in the supplementary materials you could reference and see. It does that, waits, and then when it's done, this is that callback to step function saying, I finished everything. I wrote all my files back to S3. I'm all done here. Go on step functions to the next thing. And when I write this file, this is all a file written to S3. So when this droplet runs, it downloads this file to the server, and then it knows based on the variables to run this directly. So it's like a script to run more scripts is essentially what it's doing. So let's go back and let's check the status of our step functions here. So it looks like, hey, it succeeded. It was successful in both getting the HTTPX data and then processing it. So if we go back to the DigitalOcean place, we'll see that, hey, check it out. If you remember, this first droplet we created was called brevity-HTTPX, and it's gone. So that means that the Lambda function that's checking for the shutdown ones already ran, deleted it for me, completely gone, no history of it. And it's standing up right now, our web crawl of the new data that it's found. So we'll let it go ahead and crawl, and we'll jump back to our step functions and see what happened here. One thing I'm doing with the HTTPX data that I think is helpful, and it's not out of box from the command, is when you have so many different programs and you have so many output files, it's one thing to add kind of the program name to the naming convention of the output file, but what happens when you start to aggregate the data directly within those if it doesn't have the program reference? And I found that to be fairly consistent across a lot of the tools, is that it will have the information, the URLs, the domains, but what happens when I do my aggregate analysis and I see some random domain? I have no idea, other than trying to track down and figure out the source file that it came from. Honestly, that's one of the most difficult parts, is tying it back to the original program. So what this process HTTPX does is it reads the JSON file within just Python code, pulls the JSON, and actually adds an additional 2 elements. So it adds the program name, and then it adds the base URL, because the HTTPX output actually has the full URL, has the domain, has the parameters, but it doesn't have that base. And why is the base important? The base is important for things like nuclei templates, where I don't want to just go after something.com/ and then my nuclei payload. I want it to be something.com/API/test/ whatever, and do that. And whenever I can do that, generate the distinct aliases or distinct URL, base URLs without any parameters or any additional on there, it just makes it fewer and fewer bad requests that I'm going to be sending to these programs as I do any type of fuzzing. So as the crawl goes, it's going to go through, it's going to do a similar process where I dynamically wrote the crawl script. It feeds the crawl, writes it back to S3, does all the processing analytics. And then one of the neat things that I think is really neat is Amazon has a service called Glue, and it's basically a crawler where it can crawl across an S3 bucket. So as security researchers or bug bounty hunters, we probably have hundreds of output files from the same tools over and over. So I'll continue to use HTTPX as the example. So what happens is I will aggregate all 100 plus HTTPX commands that we have across programs. I'll put it into the same directory structure within a bucket. And then I can set up what's called a glue crawler that will crawl this bucket, and it will automatically extract the data. So you can see here where it goes through, it finds, I've run the Recon so far on 91 programs. I don't have all 600 in yet. I've been kind of going slowly, trying to monitor, tune things as we go. So right now I have 91 programs. You can see there's just over 10 million unique URLs across those 91 programs that I have indexed. And then it will do a smart indexing. So it basically creates a structured index table that points to the raw JSON output files of HTTPX with these. So this is I can use the Athena service and use Presto functions and query syntax, and I can query programs now based on the HTTPX aggregate. And you can see, I believe I have the program name. These are the program name and the base URL I mentioned are not out of box from there, but from the processing, I went ahead and added those in so I can do smarter queries against it. So when we hop back to, it looks like step functions still running. We'll give it a little bit more time here to run. Let's check on, yep, you can see the server's still going. So as we're waiting, let's jump into Athena and I'll show you what I mean by some of those queries. So if we pull in all the HTTPX data, and let's use Tesla as the example. This was a sample query I wrote, but if you saw like the table syntax there, and I'll expand it here. Here's all the different things. So if you're trying to, let's say you're doing fuzzing or brute forcing APIs, you might want to look for anything with the word API in the URL, just like it's written here, and then with a status code of 200. Or maybe you don't want 200. Maybe you want to try to send payloads that are going to bypass a 403 forbidden or something like that. So this query would run. I hit run query and it returns, it looks like 2 results. We'll watch it run here. In about 4 seconds, it crawled 12 gigabytes of data in 5 seconds, and it returned these 2 results here. So let's adjust this. I haven't tested this one out, so we'll see what happens if we do a 403 status, if we get any more or any less. I don't know what'll happen here. Hopefully we have some results that'll be fun to talk about, but let's watch this run, all 0 results. That's no good. But you kind of see what I mean, where you can then start to think about, well, what do I want to start doing downstream now? Do I want to look for specific URL parameters or anything? You write this in here, and then what's cool is at the completion of every one of these queries, it outputs it into a CSV file into an S3 bucket. So if you take that ephemeral approach for a nuclei template or something, I can do the same ephemeral startup of a droplet, install nuclei, and then I can pull this query that maybe I write it so that it only selects URL. So that way I just have a list of URLs that meet this criteria, download it to the S3 bucket, and automatically pull that as my word list that feeds in the URLs that it targets from an intelligence standpoint. So I've just increased the likelihood that I'm going to have a hit without having to send millions and millions of requests that are just never, ever going to have a finding or a result. So I think that's pretty cool, and I'm really excited to dig in more and more doing some of that there. All right, so when we hop back into our workflow and step functions, it looks like our command finally completed. So let's check it out. I think one of the fastest ways to do is do the glue Athena search. So let's see if the updated table is actually successfully updated. If we do a quick Athena query here, we'll use this previous one, and let's create a new query. And then we're going to say select the URL, get the content length from here. Let's just take out the URL API wildcard and status, and let's just skip straight to program. So we have where program equals, what did we call it? We called it DEFCON Recon Village. Order by content length, that looks fine. Let's run it and just see if it worked. See what we have here. Should take about 5 seconds and check it out. Here's our program. Here's all of our URLs and ordered by content length, so we can kind of see what returned, what didn't. And I think the last thing to show is just the Recon Dashboard. So you can see I can automatically update this dashboard to pull in the data. So I have, just over 8 million rows imported here into these analytics. And I've already custom sorted by program here. I don't think I have it filtered on private invites, public invites, so I'm not going to hit the drop down. But you can see that I have 91 total programs, count of URLs. This has 8 million URLs generated in there. I have a dashboard I can look for like random response codes that might be anomalies. So if I scroll down, I bottom ranked where we have some that's a 300 response code. I don't even know what that is, but it sounds like something we should probably check out, or a 202 or a 203. If I have one result out of 8 million requests, it could be an anomaly or something. So then we can go through there and you'll see the different status codes that we have. You'll notice pretty quickly these are out of scope. There's certain things that I'm not going to attack or do payloads or exploitation, but it's still interesting to see the third-party libraries that you might point off to or do. And what I think will be interesting in the future as we cross-examine these using graph databases and things are, how many commonalities do we have across the programs as a whole? All the programs, are they reaching out to the same JavaScript libraries? Is there something that if I could go to this connect Facebook SDK.js, are there 60 programs out of the 600 that maybe have that same relationship? So if I go from a Facebook bug bounty program standpoint, find a flaw in the SDK.js file, I can submit that to Facebook. But at the same time, let's submit it to all the other programs and try to find those, double up on some of the profits around this. So those are some of the relationship techniques that you could use and apply. So, but as we wrap up today, I really wanted to thank you for checking out and just taking this journey with me. And I know I don't think I mentioned earlier, but I probably put in about 500 hours, honestly, into this project. There's a lot of code, a lot of lessons learned, a lot of trial and error, a ton of failures. And I'm actually starting to see some success. And this is finally getting to kind of the exciting part after the grind. And so feel free to reach out to me. I love talking about this. I'm excited to learn and meet a lot more people, share ideas, and learn how some of you are doing your automation. So I really appreciate your time today and enjoy the rest of the Recon Village. And I thank the team for having me. Thank you.